Okay, so real numbers are all the numbers on the number line. Any number you can imagine or think of, or even ones that you've never thought of, it has a home on the number line somewhere. Okay? So that's the general idea. Every number down here is a real number. Now, let's take a trip down memory lane. Hmm? All the numbers on the number line. Okay? Now, remember way back when you first started learning about numbers, you would count things? Those are called natural numbers. So they're also called the counting numbers. Sometimes they're referred to as natural numbers, that's a more common, but they're also called counting numbers. And they're the numbers 1, 2, 3, 4, so on and so forth, on to infinity. If you could count it, if you had infinite number of fingers to count anything, that would be a natural number. Okay? Now, so that was like what? When you were 3, 4, maybe younger. Eventually you get to school and you learn about this new number that represents nothing. What number represents nothing? That's housed here in the whole numbers. Now, the way this works is 0 is a whole number, right? But it's not a natural number. But every natural number is a whole number. So everything in the box that's inside is everything that's part of the boxes that are outside. So a natural number is a whole number. It's also going to be an integer. It's also going to be a rational number. And of course, it's a real number. So if you could think of a number that you can count, 1,000, say. So 1,000 is this, 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 and this. It's all of those. So that's how we're going to use this chart. Now, any questions? Let's move on to integers. So we know natural, we added 0. Then 5th grade, 6th grade, 7th grade, and definitely now, we learn about their counterparts on the negative side. -1, -2, -3, -4, on to negative infinity. Okay? So those are the numbers that are purely integers, but they're not whole and they're not natural. So now, write those down and think about this. The number 3, is it an integer? Remember, if it's down here, it's everything that's above it. So it would. So the number 4, the number 1,000. So now, the number -5, it lives here. Is it a natural number? It's not, because it can only be everything above it. So the number -5, it lives here. It can't be a whole number. It can't be a natural number. It has to be just an integer, but it's also rational and real. So something here is everything above it. Okay? Does that make sense? Okay. All right. Moving on. What comes next? Rational numbers. So look at this. Everything down here is going to be a rational number because it's below it. But then we're going to see why in a minute. Okay. Rational numbers are all the numbers, write this down, please. All the numbers that can be written as fractions. Every number that can be written as a fraction is a rational number. So let's think about this for a minute. Like say, take the number 2. It's a natural number, but technically it's a rational number because I can write it as a fraction. How do I write the number 2 as a fraction? Well, I need the 2 in the numerator over, bless it, 2 over 1. That's how we get these numbers as fractions. -4 over 1. -3 over 1. So I can write those as fractions, so they're rational numbers. So everything here, even 0 over 1, right? It's 0, but it's still a fraction that way. Okay, what numbers do you think live here but don't live down here? Yeah, so it can be written as a fraction. So can you think of any fraction that doesn't look like over 1? What kind of fractions would be like not over 1? How about 2 over 3? Just a proper fraction. That's a fraction. It lives here because it's none of these down here, but it lives here. So that's just a rational number, but it's also a real number, 2/3. How about, remember mixed numbers? It has a whole number part and a fraction, like -1 and 3 over 5, -1 and 3/5. So write that down, -1 and 3/5. Any mixed number is a fraction. How about decimal numbers? Like say 0.23. 0.23. That's what we call a terminating decimal. So it ends at some point. It could be like 10 digits long, but it ends. It's a terminating decimal. I can write that as a fraction. It's 23 over 100. So any terminating decimal can be written as a fraction. How about 0.23 with a bar above the 3? Well, bar above both of them. Let's make it fun. 0.23232323. I can write that as a fraction. The ones that go on forever, just repeating the same pattern. Am I allowed to write those as a fraction? Actually, I can. I'll tell you what it is too. So just like 23 terminating is 23 over 100, 0.23232323 on forever is 23 over 99. And if I had another digit, 0.231, 0.231, 231, 231, 231, that would be 231 over 999. And if I had one more digit past that, say a 7, 2317, 2317, that would be 0.2317 over, just add another 9. Okay? And if I had another digit past that, I would add another 9. Another digit, another 9. So these can be written as fractions. This can be written as fractions. That can be written as fractions. Can you think of any other numbers we can write as fractions? How about percents? Can I write a percent as a fraction? Yeah. 24%. That's 24 over 100. Yeah, you remember. So percents. 23. I'm really stuck on 23. So percents can be written as fractions. So these are all types of numbers I can write as fractions. So they're rational numbers. And they're also real numbers. Now, the definition to be rational is all the numbers that can be written as fractions. Let's think about what makes something irrational using that definition. Do you notice they're not connected at all? They're just Either you're rational or you're irrational. You can't be both. So we want something the opposite of this. What do you think would be the opposite of all the numbers that can be written as fractions? Any thoughts? All the numbers that cannot be written as fractions. So over here, we write all the numbers that I cannot write as fractions. So write that down. All the numbers that cannot be written as fractions. And it turns out, oops, got to spell this correctly. All the numbers that cannot be written as fractions. It turns out that there's more of these irrational numbers than rational numbers. All the numbers that cannot be written as fractions. There's more of these than those. A famous mathematician asked the question in the 1800s, which are there more of, rational numbers or irrational numbers? He thought there were more irrational numbers, but he died before he could figure it out. Then like 80 years later, after he passed away, someone figured out there's more of these. They proved it. Mathematicians, that's what they do. They ask questions, and then either they or someone after them, because the math is really advanced that they need to use, proves it. They have to prove these things. So he showed that there are more irrational numbers. Now, it makes sense that there are more irrational numbers because that is the most famous irrational number, pi. Okay, whenever you say irrational numbers, the first number that should come to mind is pi. It's the most famous.
Google.
Yeah. Google will tell you. Okay, now, what do you think makes this number impossible to write as a fraction? Yes. Yes, that's exactly it. It's an infinite number, goes on forever and ever. And unlike, the repeating decimal, there's no pattern. Someone, again, a mathematician asked a question, what if pi maybe 2 billion digits down starts having a pattern? They thought maybe that happens. I don't know. Guess what they had to do? They had to prove it. Someone proved that there's never going to be a pattern. There's never going to be one point that, 8 billion digits down, it's going to start repeating. Nope, not going to happen. So it's irrational. Okay? And the reason is it goes on forever and there's no pattern. Can you think of any other numbers we've seen recently that have that? Well, first of all, let's write this one. Pi is most definitely irrational. It's a special kind of irrational. They call it transcendental. And at some point when I was studying math in college, I knew what transcendental means, but at this point I forgot it. But I do remember that's like a special kind of irrational number. So pi and any number you calculate with pi, like 2 times pi, is irrational. Okay? Pi divided by 7, irrational. Pi take away 8, it's irrational. All of those combinations, irrational. So there's an infinite number of those. But what other numbers that aren't associated with pi are irrational? We've been working with them. I'll give you a hint. We learned yesterday that, I'm going to have to cover this up for a second. Remember we were using this to calculate some yucky square roots yesterday? So if I ask you for the square root of 25, what's the answer? 5. If I ask you for the square root of 36, 6. But how about all those numbers between 25 and 36? Those are all yucky numbers, remember? So that tells us one thing. The square root of 25 is 5, right? That means the square root of 25 lives here because it's actually 5. So some square roots do live over here. For example, the negative square root of 36 lives here. Because what's the answer to this? Negative the square root of 36. Well, what's the answer for the square root of 36? 6. But if I add the negative in the front, it makes it negative 6. It's negative 6. So negative square root of 36 is actually negative 6. So it would live here because we know the answer, and the answer is an integer. How about the square root of 26? Is it nice or yucky? So it lives here. Let's take a quick peek at the square root of 26. It's 5.1 something, probably. 5.0990. So it's 5.0990 1 ... It goes on forever and ever, and there's no pattern. Okay? What other square roots might be yucky? Let's see if we can figure that out because they live here. Look at this. Square root of 100 is 10. Square root of 121 is 11. How about everything between yucky? So any number between 100 and 121 would give us a nasty square root, a nasty decimal number. Can someone pick a number between 100 and 111? It's yucky. It's 10.535 something. Most square roots are yucky. They go on forever and ever and ever. Can someone give me a square root that's not yucky that would live here? 121. Square root of 121 is 11. It's a nice whole number. So it would live here with the natural numbers. Okay. Does that make sense? And then square root of 2. That's yucky, right? It's one of the more famous square roots. What do you think would happen if I multiplied this by 5? Would it change its yuckiness? Okay, multiply it by 10 times 10. Is it any less yucky? Nope. So even multiplying these square roots with, numbers. So 10 times the square root of 2 is still yucky. It's 14.1421 ... So most square roots, unless they're on our magic list here, will be irrational. So that's really most numbers. So basically, irrationals are on this side, rationals are on that side, and they don't mix. They don't get along. Well, I don't know if they get along, but they just don't mix. So that's how we classify numbers. So let's recap. Anything here, from the lower you are, the more categories you have. Take, for example, the number 5. The number 5 is a natural number. It's a whole number. It's an integer. It's a rational, and it's a real. How about the number 2/3? What are the categories it's under? Well, where's it at? Where's it living? And what's above it? Real. So 2/3 or any number living here is just rational and real. Any number living here, like say -1,000, is an integer, it's rational, and it's real. So we're going to practice all that right now. You want to keep this handy. Everyone ready to do the questions here? Let's do it. So, first question. List all classifications of the number, and they want us to look at -1. So let's see where -1 lives. Find -1. Here it is. So what classifications does it have? It's a integer, it's rational, and it's real. So let's write those down. Integer, it's an integer, it's rational, and it's real. It's all three of those. Okay, what's our next number? Square root of 5. Where does the square root of 5 live? Yeah, but is it on the rational side, irrational side? Huh? Rational. How much? Let's see. What's the square root of 5? It's yucky, right? Oh, no. Just 5. Just the square root of 5. It's not on our list. It's yucky. So it lives here. So what is it? It's irrational and real. Pretty much any number here is real. So it's irrational and real. Okay, make sure you're writing this down. Don't drift on me. All right. Find where 0 is. Our next number is 0. Where's 0? So what are the classifications for 0? It's a whole number, it's an integer, it's rational, and it's real. So it's all of those. It's a whole number, it's an integer, it's rational, and it's real. It's a lot of things. Okay, all you have to do is just see where it lives, and everything above it is part of its classification. Okay. So next we have the terminating decimal, 0.2379, and it ends right there. Where does it live? Rational. So 0.2379 lives here in the rationals. So it's rational and it's real. So in the next one, we're doing the same thing. We're just checking off boxes. So let's start with the fraction 3/5. Where does it live? Rational. So we just check off rational and real. So 3/5 is rational and real. Just those two. Okay. Next we have the repeating decimal, 3.52, then 67 repeating. Where does it live? Rational again. So rational and real once again. Okay. Next we have the number 9. Where does the number 9 live? What's its final resting place? Yeah, it's a natural number. Any number you can count would live here. So 9 lives here. So it's natural, it's a whole number, it's an integer, it's rational, and it's real. It's a whole lot of things. Okay? So it's a natural number, it's a whole number, it's an integer, it's rational, and it's real. Yeah, just not irrational. Because here's where the irrational numbers are. The moment that you're rational, you can't be irrational. Okay? All right, next we have some true-false questions. Okay? It's either true or false. if a number is rational, then the number is an integer. If it's rational. Okay, so the question is, are there rational numbers that aren't integers? Yeah, there are. All of these. Yeah. Yeah, that would be a false. If a number is irrational, then it is also real. Oh, we're getting true or false. Well, irrational numbers live here. Are they real numbers as well? Well, remember, this covers everything. So if it's irrational, it's also real. So that's actually true. Negative 12 is irrational. And negative 12 is rational. I'm sorry. Negative 12 is rational. Lives here and then it's rational. So it's true. Pi is a real number. True. Yeah, pi lives here, so it's real. 0 is an integer. Look where it lives. Always go back, find where it lives, and then that'll help you determine. It lives here, so it's everything above it. So it is an integer. 0 is an integer. This one? Okay. 9.8623 blah 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 is natural number now. It would live up here, so this one's false. Negative 1/6 is irrational. False. It's actually a rational number. Okay. Short answer. So this is just usually a number that they're asking for. Name a number that is whole but not natural. 0. 0 is a whole number, but it's not natural. I think the next one you can have different answers and still be right. Give an example of an integer that is less than negative 8. Here's the integers. Negative 9, negative 10, negative 11, anything to the left. Think of your number line. So name your favorite negative that's smaller than negative 8. Name an irrational number other than pi. There's a bunch of them, right? There's some right here. Other than pi. The square root of what? 2. There you go. That's irrational. Square root of 27. The square root of 37. The square root of 101. There's an infinite number of non-pi irrational numbers. Okay? Keep this handy. Keep this handy. Okay? Before we go on to the individual assignment, we're going to practice a little bit. So in the folder, in the lesson 9 folder, we're going to do something real quick.